Welcome back, everybody. This is Professor Reitz, and this is lesson 14, the properties of exponential and logarithmic functions. And in this first video, you're going to see that today most of the videos are just going to be working examples. And this first video is a quick review of the properties of exponents and of logs. The assumption is that you know this already, but if you don't, I'll talk your way through these briefly. And then we'll look at some examples on how to apply them. And our focus mostly is going to be on properties of logs, but since they all come from properties of exponents, we'll start with those. So properties of exponents, let's just look at the first one here. It says b to the power x plus y is equal to b to the x times b to the y. And this may look more like a more familiar formula if you think of it backwards, starting on the right side. If you have b to the x times b to the y, if the bases are the same, then you can combine those two powers together by adding the exponents. And that's what that's saying. And similarly, for the second one, b to the x over b to the y, you could combine them when you divide. You combine them by subtracting exponents. You put that minus in front of whatever the exponent was that was on the bottom. And of course, these rules also work the other way. So if you have something of the form b to the x minus y, you're allowed to split it up as b to the x on top and b to the y on the bottom. And then finally, if you have a power raised to a power, so b to the power x to the power n, we combine those by multiplying the exponents together, b to the power n times x. Okay, so let's look at what happens with logarithms. So if we have a log function, so we have a base b, and b has to be positive, and it can't be equal to 1. And then if we have numbers x and y, positive numbers that we use as our inputs, then here are the rules of logs. And if you look back at the rules of exponents, you'll see that there's a correspondence between rules of exponents and rules of logs. I'm not going to talk more about that now. Let's just go through the rules. So the first one says, if you have two logarithms added together, and if the logs have the same base, log in base b, log in base b, you can add two logs together. The way that you do it is you combine them into a single log, and the things inside the logarithms, the x and the y, get multiplied together. Yeah. So when they're apart, they're added, but when you combine them into a single log, they're multiplied. The stuff inside is multiplied. And similarly, if you have a log in base b with two things multiplied inside, you can split it up into two logs, the log of the first one plus the log of the second one. Now, there's a similar rule for when you subtract two logs. The subtraction of two logs corresponds to division. So you can combine log in base b of x minus log in base b of y, combine them into a single log, and inside you get x over y. Yeah, and it's important that the one that was after the minus sign, the negative one, is the one that ends up on the bottom. Then finally, this one is really helpful. This says that if you have a log times a number, that you can bring that number up and put it as an exponent of the thing inside the log. Or similarly, if you have a log of x to a power, you're allowed to bring that power out and multiply it in front of the log. So those are somehow the three basic rules of logs. And then there's one more rule of logarithms, which is just a change of base formula. And this is going to be helpful for a number of reasons, but especially in plugging things into our calculator. So I just want to remind you that there are two special bases. So recall, if we're looking at base 10, this is like the log in base 10 of x. We write that without the 10. We just write log. So log of x. And typically your calculator will have a button that has log, and it'll say log with no base on it, and that means it's base 10. Okay, the other one that's important is when we have the natural log, that's the base called e, where e is this number that's approximately equal to 2.718 ... Natural log. And the natural log, we write ln x. And when you see this ln x, just know that ln x means the log in base e of x. Why do we use this weird base e? It turns out that e is a magic number, and we're going to find out more about that later in this class, and especially you'll see why when you get into calculus. Now, why is this important? Well, it's typically the case that a calculator may not have log in in any base that you want. It may, but modern calculators often do. But they will almost always have a log button, that's the log in base 10, and the natural log button, that's the log in base e. And what the change of base formula says is if you want to change from one base to another, here's how you do it. So suppose that we have a log in base 5 of the number 7. This is like asking, if you just remember what logs mean, this is like asking, okay, if you have the number 5 and you're raising it to a power, what power do you have to raise it to in order to get an answer of 7? And if you want to calculate this, it's a number between, 1 and 2, because 5 to the 1 power is 5, and 5 to the 2 power, 5 squared, is 25, and 7 is in between there. So it's a number between 1 and 2. It's 1 point something. And if you want to convince your calculator to give this to you, we don't have a log in base 5 button necessarily on our calculator. But we do have a plain old log in base 10 button, or log button, and we do have a natural log button, and you can use either one of those as follows. Here, what we're thinking of is that base b is 5, and we want to change it to the base a. Let's make the base a be equal to 10. This is going to be with an eye towards using the log button in the calculator. And what this says is if you have the log in base 5 of 7, looking back at the change of base formula, you can do it's equal to a fraction in a new base, log in base a over log in base a. And the things that go inside, on the top log goes the x, whatever was inside the log. And the thing on the bottom is just the b, the base of the log from over here. So this guy is equal to log of 7. Remember, that means log in base 10 of 7. Over log of 5. Log of 7 over log of 5, this is something that you can plug into your calculator and get an answer. And if we open up a calculator and take a look, I'll do it in Desmos. Here we have to just switch over to the letters so we can type log of 7, and then we're going to divide by log of 5, and Desmos tells us in the small gray box there, it tells us that the answer is 1.2090 ... or approximately equal to 1.21. Let's go ahead and enter. This thing is equal approximately to 1.21, and I'll make it clear that that's approximate. Okay, so you'll notice that we were able to get that numerical answer only using the log with base 10, which is log. In order to calculate the log in base 5 of 7, we do the log of 7 over the log of 5. And amazingly, it works just the same if you do the natural log of 7 over the natural log of 5. The natural log of 7 is not the same as the log of 7. The natural log of 5 is not the same as the natural log of 5, but natural log of 7 over natural log of 5 will also give you 1.21. And if you want to plug in your calculator ln7 over ln5, you'll get that same answer. Okay, so that's a recap of these properties of log functions. And what we're going to do now is we're just going to use these rules to help us work with logs in various ways. Let's go ahead and do it. Okay. Example 14.1, and you can refer to this on the lesson itself, and it also appears in your textbook if you want to look at it there. Let's talk our way through these. So, part A says, the instructions say combine the terms using the properties of logarithms so as to write as one logarithm. And so what we want to do is just combine stuff together as much as possible. this expression, 1/2 ln x plus ln y, the first thing that I am going to do is I'm going to take the number in front of the natural log here. Remember, the natural log is just the log in base e, so all of these properties, these rules of logs here apply. And I'm going to use the rule down here, which says if you have a number in front of a log, you're allowed to move that number in and put it as an exponent in the log. And so this 1/2 in the front of my log is going to move in and become a power on the x. So this is the natural log of x to the power 1/2 plus the natural log of y. And now what we have is a natural log plus another natural log. These logs both have the same base. They're both in base e, since they're natural logs. And we have a rule for these as well. It's this rule here. It says if you have a log plus another log, and they have the same base, then when you add them together, you're going to get a single log, and inside you'll multiply the things that you had inside the two logs before. So let's go ahead and do that. This thing is going to become the natural log of x to the 1/2 times y. So this is it. This answer is perfectly fine like that. If you wanted, there's one more thing you could do, which is in general when you have a power that's a fraction, a 1/2 power, we can convert that into a radical. A 1/2 power is a square root. And so we could also write this as the natural log of radical x times y. And I would accept either of these answers, and that's sort of a handy trick to know. That's something we'll use later. Okay, that's part A. I encourage you to pause this video and go ahead and give parts B, C, and D a try. See what they see how they go. All right, if you're back, let's go ahead and work our way through these. So part B, this one is 2/3 times the log of x squared y minus the log of xy squared. And of course there's different ways to attack this problem. What I'm going to do is simplify the stuff inside first. This one is a log, which means since there's no base there, it means that the base is 10. That's one of our two special logarithms. And this log is also base 10, and we have a log in a base minus a log in a base. And the rule is when you subtract two logs, you make a single log with a fraction inside, and this goes on the top, this goes on the bottom of that fraction. And this 2/3 I'm just going to keep out in the front. So how does it look? Like so. 2/3 times the log of, and the x squared y goes on the top, and the xy squared goes on the bottom. Now, we have this nice fraction inside with some stuff that will cancel. In particular, we can cancel the x on the bottom. Whoops. Let me try that again. We can cancel the x on the bottom with one of the x's on the top, leaving just an x on the top. And we can cancel the y on the top with one of the y's on the bottom. And so this thing altogether gives us 2/3 times log of, and let me see, we had an x left on the top and a y left on the bottom. And then the last thing we're going to do is use that that third rule to take this number in front of a log and move it to make it a power of the thing inside. Let's go ahead and do that. This is log of x over y to the power 2/3. Okay, so this is a perfectly acceptable form of the answer. If you would like to convert that fraction power into something like a radical, the way that it works is for a 2/3 power, the root is going to be given by the 3 that's on the bottom, so this is going to be a cube root, and then the 2 is going to be like a squared attached to this thing. So we can rewrite this one more time. I'm fine with leaving it in the version that's boxed here, but you can also rewrite it like this, and it would look like this. We're going to do the cube root of x over y, and the x over y is squared. So this is a fine version of the answer to this. I would accept either one of them. Okay, Pause, go work on problem 3, part C, and then come on back and we'll go through it together. So let's see, for part C, I wonder if I can cut just a piece of this thing out. And then here we go. This is my C. We'll add it down here just so that I can keep track of it. And for part C, let's go ahead and do this. This is 2 ln x minus 1/3 ln y minus 7/5 ln z. So here's how we're going to handle this. I'm going to take each of these natural logs. First of all, they're all natural logs. So they all have base e. And each one of them has a number in front, and I'm just going to move that number up into the power. So let's see. The first one, 2 ln x, is going to become ln of x squared. The minus 1/3 ln y, now you have a choice. You can move the minus 1/3 into the power, in which case you would leave a plus in the front. Or you can just move the 1/3 into the power and leave a minus in the front. It's up to you which of those options you take. I'm going to leave the as a minus ln, and then here make it y to the 1/3 power. You'll notice I've dropped writing the parentheses inside. Parentheses, once again, you have to have them if there's any confusion about what you're writing, but in these cases it's fairly straightforward, so you can get away with dropping them. And then for the final term, I'm going to do a similar strategy, which is keep it as a minus, and that one is natural log of 7/5. Z to the 7/5. Okay. The next thing that we're going to do is combine these logs, these natural logs, by using the rule that's to subtraction, and we'll do it in 2 steps. First, I'll combine these two together, and then I'll combine the result with this one. So combining these two, since the logs have a subtraction, that means that we're going to get a single natural log with a fraction inside, and that fraction will have x squared on the top and y to the 1/3 on the bottom. And then we still have this minus ln of z to the 7/5. Now I'm just going to use that rule again. This time we're going to get a fraction with this on the top and this on the bottom. That's going to look a little bit messy, but we'll be able to simplify it. So this is the natural log of, maybe I'll put in parentheses because it's getting messy in there. There's a big fraction. On the top of that big fraction is the little fraction x squared y to the 1/3. And on the bottom of that fraction is this z to the 7/5. And now to simplify this little fraction over a fraction, we can take this guy from the bottom of our big fraction, move it up to the top and flip it, put 1 over it, and multiply it by this guy. And the way that that will look, keeping everything just inside that ln for now, is it will look like so. We're going to have x squared and y to the 1/3, and then times 1 over z to the 7/5. And then we can just combine by multiplying those, and we're going to get natural log of x squared on top, y to the 1/3, z to the 7/5 on the bottom, and that's our final answer for this one. Okay, take a look. We have one more to go, so this is our answer for this guy. One more to go. Take a look at part D, and I'll go grab a copy of it and bring it down for us to look at. Okay, so let's take a look at this one. What I notice here is that these are both log in base 2, which is great because we can combine them together. And here, a lot of the complication is the stuff that is inside them, here and here. Now, there's also this plus 5. If this was a log of base 2 of 5, then we could combine it with this log. But since this doesn't have a log in it, we're not going to be able to combine it with this log or this one. So we're just going to leave that 5 plus on the outside. So for my first step, I'm going to take this log in base 2 of this guy and this log in base 2 of this guy. And since they're subtracted, I'm going to make a fraction inside of my new log in base 2. I keep the base the same. So starting from the beginning of my expression, I have 5 plus, and then we have a log in base 2 of, and inside will be a fraction on the top, a squared minus b squared, and on the bottom, a plus b. Now it looks like we're basically done. We cannot do anything to combine the 5 with this log. However, there is one more thing that we can do inside here, which is this a squared minus b squared we can factor. This is one of those ones which if you just know it, if you have it in your head, that's great. If you don't, you can write two parentheses next to each other and see if you can figure out how to factor that thing. What you're going to end up with is this, a plus b times a minus b. And if you try just multiplying that out using FOIL, you're going to see that you get a squared minus b squared. The bottom of this fraction is a plus b. And what's nice about this is that we now see that we're able to cancel a plus b on the top with a plus b on the bottom. And so altogether what we have is 5 plus log in base 2 of a minus b. That's my final answer. Okay, guys. That's it for this example. Now we're going to go on. We have one more set of examples to look at here in practicing with logs. Let's take a look. Let's see if we can find my other examples. Where did they go? Here they are. Okay. Example 14.2. Write the expression in terms of elementary logarithms. I feel like these instructions are needlessly complicated. All they're getting at is to try to break these logs up as much as possible. That's our goal. So it's like what we did in the previous problem, but kind of doing the opposite. Okay, let's go ahead and we'll look at them one step at a time. The natural log of radical x to the 5 times y squared. Well, you'll notice that this is a single natural log, and inside there are two things, the radical x to the 5 and the y squared, and they're connected by multiplication. And because of that, when you have multiplication inside of a log, you can break it up into two logs, and those two logs will be connected by addition. Multiplication on the inside of a log corresponds to addition outside. So this is the natural log of radical x to the 5 plus the natural log of y squared. This is a pretty good start. In the second one, I can take the power, the squared, and move it out to in front of the ln, in front of the log. And for the first one, what I want to do is, we don't have a rule for radicals in logs, but I can convert that radical to a 1/2 power. And that looks like this. This is the natural log of x to the 5th to the power 1/2. Plus, here I'm going to bring the 2 out, ln of y. Now, the rules of exponents say that this x to the 5 to the half, we can combine those by multiplying the exponents, 5 times a half, and that's just going to give us a power of 5/2 on that log, so that's natural log of x to the 5/2 plus 2 ln y. And then finally, this power on the x, we can use the rule that says a power on the thing inside the log can be brought out into the front. Let's go ahead and bring it out to the front here. This is 5/2 ln x plus 2 ln y. Okay, with that in mind, go ahead and try parts B and C. See if you can sort them out. And I'll work through them here, and that'll be the end of this video. I know these videos are a little long, but they're just primarily working examples, and that takes a certain amount of time. I assume that you guys are skipping through them as needed. I hope that that's useful. Let's see. Okay, so part B. Here we have a log. Now, there's no base written, so that's the log in base 10 of, and then inside we have a radical, and then under the radical we have a radical x times a y cubed. Okay, here's how we're going to do this. We're going to do this one step at a time. When I look at this, I see that there's a multiplication in there, but that's not the thing that's first inside the log. Inside the parentheses, the first thing that happens is this outer radical here. So that's what we're going to take care of initially. Take this radical, and what can we do with the radical? We can convert it to a power, to a 1/2 power. And since that radical is over this entire radical x times y cubed, our power had better apply to that entire thing, which means we'd better put that in parentheses with the power outside the parentheses. So here's how I'm going to do it. I'll do radical x times y cubed, whole thing to the power 1/2. And what we have now is we have a log with stuff inside all raised to this power. And that means that that 1/2 power can come out in front. That's using our rule for exponents and logarithms. So 1/2 log of radical x times y cubed. Looking at what we have left, the radical x we can convert into a power of 1/2 on that x. Let's go ahead and do that. We still have this 1/2 in the front, and then we have a log with x to the 1/2 and y to the 3. Okay. Now, there's two rules that are tempting to use here. One is the rule to do with powers, bringing the powers out to the front, and the other is the rule to do with multiplication. And unfortunately, we cannot use the powers rule to bring these powers out to the front because that rule only works when everything inside the log is raised to the same power. You can bring that power out to the front. That was the situation over here. The entire thing inside was raised to a power, and we were able to bring it out. Okay, but here we don't have, this part is raised to a 1/2 power, this part is raised to the 3rd power. So what we need to do first is split this up using the rule about multiplication. A log of two things multiplied, we can split that up into two logs, a log of the first thing and log plus the log of the second thing. Now, careful, we have this 1/2 in front. It's multiplied by our original log. So when we split that original log up, we have to make sure that we keep that 1/2 multiplied by everything we replace the log with. So I'm going to make parentheses 1/2 times, and then inside we're going to have a log of x to the 1/2 plus a log of y cubed. And now what I can do is inside these parentheses, here and here, I can go ahead and use this rule again to bring those powers into the front. So we'll have a 1/2 times parentheses 1/2 log x plus 3 log y. And the very last thing that I can do here is, we've basically done all the log simplification we can, but I can multiply this 1/2 through. There are two terms inside. We're going to multiply 1/2 times this and 1/2 times this, and we just multiply it by the number in the front. That's the part that goes together. So 1/2 times 1/2 is 1/4 log x, and 1/2 times 3 is 3/2 log y. And that's our final answer for this one. All right, that's B. Go ahead and pause, work out C, and we'll come back and take a look at it. Let me grab a copy. These are a little bit squished together, I admit. Okay. So, for part C, what do we have here? Well, it's a log in base 2, that's worth noting. However, our process is just going to be the same. We'll just keep it as log in base 2 everywhere we do it. And then inside, we have this cube root and then a fraction, and then there's irritating stuff inside the fraction. So here's what I'm going to do first. I am first going to convert that cube root into a power. It's going to be a 1/3 power. So this is the log in base 2 of, well, the fraction x squared over y radical z. That whole thing is under the cube root, and so that whole thing gets a power of 1/3. And what you'll notice is that now what we have is a log, and inside, the entire inside is raised to a power. So we can use the rule that allows us to bring that power out to the front. there is, so you know more than one way to approach this problem. You should get the same answer in the end. So if you did it slightly differently than me, that may be all right. Another alternative would be to distribute the 1/3 power through everything inside first. So that's an alternative. So 1/3, I'm going to do it this way. The 1/3 comes out in the front, and then this is still log in base 2. And inside it, we have now x squared over y radical z. Now the rule that I want to use next is to split up this log. Since it's one thing divided by another, we're going to split it into two logs where we have the log of the first one and then minus a subtraction log of the second one. And since the 1/3 is in front of this log, the 1/3 will just stay in front of the entire thing when we split it up. This is 1/3 times log in base 2 of x squared minus log in base 2 of y radical z. Okay, we're doing great so far. There's a couple of different things that I can do here. For example, this x log of x squared, I can take the squared and move that into the front. So if we start, let's see, I keep my 1/3. I have 2 log in base 2 of x. And then, let's see, for the next part we have to be a little careful. This minus in front of the log, well, I want to split this log up because the y and the radical z are connected by multiplication. And so we can split that up so that there is an addition sign in between there. Yeah, we can split it up into the log in base 2 of y plus the log in base 2 of radical z. The thing we have to be careful of is this minus is in front of this log, which means that the minus had better be in front of everything that we replace this with. So the way that we do it is we keep the minus here, and then we put parentheses in, and we use our rule to split that log in base 2 into the log in base 2 of y plus the log in base 2 of radical z. Now, the important part is that this minus, we're going to distribute it through here, which means that the log in base 2 of y will be negative, and the log in base 2 of radical z will also be negative. So I'm just going to do that distribution step next. This is 1/3 times 2 log in base 2 of x minus log in base 2 of y minus log in base 2 of radical z. Now, there's one more thing that I see I can do here, which is that this radical z, I can change that to z to the half power. And you may be looking ahead a step and thinking, if I have a 1/2 power on that z, I can bring it out into the front. And that's exactly what I'll do in the next step. So log in base 2 of y minus log in base 2 of z to the half. And then this z to the half, that's going to move out in front there. I forgot my closing parentheses. There we go. So this is equal to, it's 1/3 times 2 log in base 2 of x minus log in base 2 of y minus 1/2 log in base 2 of z. And then, as a very final step, I'm going to get rid of those parentheses, the big ones here, by multiplying this 1/3 through the whole thing, times each of the 3 terms inside. And that 1/3, when I multiply it by the 2 log base 2 of x, I get a 2/3 log in base 2 of x. And then I'm going to have a minus 1/3 log in base 2 of y. And then 1/3 times 1/2. When we multiply those, we multiply the numerators together, 1 times 1, and that's 1. And the denominators together, 3 times 2, that's 6. So this is minus 1/6 log in base 2 of z. And there you have it. This is the final answer for part Z. So, sorry, part C. Now, this has been a long video. I recognize that. It's almost all examples. Please feel free to email me if you have questions or leave a comment on the Open Lab. And the main point of all of this is we're really practicing using the rules of logs so that we can use them to solve equations. And that's what we're going to be doing in the next 2 videos. All right, thanks everybody.